It is 3 a.m. The pager alerts are triggering, and a critical data extraction process has crashed. A single broken parser halts the pipeline, and the engineering team scrambles to find the source. The root cause is sitting right in the logs. The pipeline expected a neat, strictly typed JSON object from a language model. Instead, the model decided to be polite. It prepended its response with, "Sure, here is the data you requested," invalidating the payload and breaking the parser instantly. For years, developers tried to solve this formatting problem by begging. We wrote prompts saying, "Respond only with valid JSON, do not include extra text." We were treating syntax execution like a behavioral request. It usually worked, but usually is a statistical trap in software engineering. When a system processes 1 million API calls a day, a 99% success rate guarantees 10,000 system-breaking parsing errors. Starting in 2024, AI providers overhauled text generation by moving from statistical requests to physical enforcement at the engine level. Language models predict the most plausible next word based on their training. That probabilistic nature is brilliant for writing prose, but it is inherently dangerous for strictly typed data pipelines without an absolute structural enforcement layer wrapped around it. To understand how to enforce that structure, you have to understand how we instruct these models in the first place. Picture a brilliant, well-read intern who walked in the door 5 seconds ago. They know nothing about your project, your audience, or your format requirements. They need a brief. This illustrates the PTCF framework for briefing models. P is persona, calibrating tone and vocabulary. T is task, providing a specific action and finish line. C is context, supplying audience and constraints. F is format, dictating the final answer's shape. Persona, task, and context effectively shape the model's reasoning. But the format block was ultimately just a polite request to an unpredictable text generator, which is exactly why it frequently broke downstream code. Let's look at the tangible impact of a structured brief by processing the exact same dataset through 2 different requests. In the before section, a vague request fails, generating generic prose that cannot be parsed. Look at the after section. By injecting a specific persona, task, context, and format block, the output is drastically transformed into a highly actionable ranked data structure. A precise prompt acts as a conceptual mold for the model's reasoning. Yet, even with a perfect prompt, you still rely entirely on the model choosing to follow those format instructions. This vulnerability is where constrained decoding enters the picture. It is the exact computational mechanism that physically forces a language model to adhere to a requested data shape. In standard text generation, the model selects any plausible next word based on training weights. With constrained decoding, a JSON schema compiles into a grammar layer that actively monitors sampling. As tokens generate, this layer masks out invalid characters, forcing their probability to 0. In August 2024, OpenAI released structured outputs utilizing this mechanic. By actively masking invalid tokens, schema adherence jumped from under 40%. With ATI-level guarantees, a professional misconception emerged. The idea that strict schemas and dynamic context engineering have made prompt engineering obsolete. This diagram clarifies the division of labor. The JSON schema guarantees shape, but the prompt guarantees substance. A perfect schema with a vague prompt outputs perfectly formatted garbage. Persona, task, and context are required to ensure correct logic populates that rigid container. Context engineering and structured outputs do not replace the prompt brief. They rely on it entirely as their foundational reasoning engine. For developers pushing to production, the instruction is clear. Stop asking for JSON in plain English. Instead, define your output schemas directly in your code using libraries like Pydantic or Zod. Then pass those schemas to providers using their strict parameters. You use strict true for OpenAI, strict tool use for Anthropic, and response schema for Gemini. This workflow allows developers to write the data model once in native code and pass it directly to the API without translation layers or hope. Stop begging the model for structure. Define the logic in the prompt and clamp the mold shut at the engine level. Achieving 100% type-safe, structured output eliminates the primary point of failure in data pipelines, creating the reliability needed to scale these models into production.